Good morning, kids. Today we'll discuss the problems about the lift bolt or ball lift or particle dropped in a lift, in accelerating lift. What is the time taken by the ball to reach certain point in a lift? So these are the particular questions what we'll be discussing. So I'll start with this one. A ball is released from rest at t equals 0 in a lift. Okay, there's a ball. So here I'm releasing this ball from rest. There's all everything at t equals 0. Fine. That starts moving down with an acceleration AL. So the lift what happen will start moving down. And the ball is released from rest. And the lift also will accelerate from rest. After what time the ball will strike either the floor or the ceiling that we have to calculate here. So I'll start this one. I'll give the information. The ball is released from rest, both t equal to 0. The moment we release, what are the things the weight mg will act? And the lift starts moving down. So after some time, what we see is just for our convenient purpose, we are taking this one after some time. This is it after some time t. I'll assume that the ball will come and strike the, and the lift will have some velocity. This is what happens to the ball. This happens at time t. Now we have to calculate this particular thing. So what is the lift? It has this particular thing has ascended. I'm taking some reference pointer. What is the reference point? I'm choosing the, I'm assuming that the ball will strike the floor. After some time, what happened where that particular floor is here? And I'll give the red some color for it. After some time, look at the floor of the lift. How much of height it will descend? It will descend h. Similarly, what happens to the ball? The ball will move from here to here. There's a distance moved by the ball. It's all about, see, like, hey, we should have this imagination. We can't just write some formula. We should understand what actually happening. Then we'll go for it. So it is going to have the free fall acceleration. The ball will fall freely. Then what is our entire formula? We are discussing the first case. When the lift is moving with an acceleration 9 meters per second square. Whatever the acceleration of the ball, 10 meters per second square. Both will accelerate from rest. Then what is the formula? Displacement of the ball with respect to lift. Lift means I'm writing 1, this 1. I'll write it. Final minus initial UBL time taken plus ABL t square. The equations of motion only we are writing in this way. Then what is the final position? What is what do you mean by SBL? Position of the ball with respect to floor of the lift finally at time t. What do you mean by SBLI? Position of the ball with respect to floor initially. So how you write SBL? It should be like a SBF minus. So we are going to write this. There's a first problem. No, let me expand here. AB minus AL T square by 2. Finally, where it is, the ball, this is a final. This diagram is final. This diagram is initial. So shall I'll take downward as positive. So plus H, plus H. Initially, ball at what height it is? Minus 10. This one. This distance, because all the distances I'll measure this one. This is H equals 0. So where the ball is? Ball is at a height of minus 10 meter. No. Why plus H? Because we are measuring anything downward, we should take it as positive. Anything upward, we should take that as negative. And this particular point is H equal to 0. Okay, are you justified? This one? Then minus of. Let me increase the font size. Minus of this one. What is the left initially? Now you have to ask questions of why you are writing this 0. I'm taking this reference. Where is the floor of the lift at equals 0? At H equals 0 only. So I'm taking this floor as 1, L I'm writing it, equal to initial velocity of the ball, 0. Final velocity of the ball, 0. Acceleration of the ball or bolt, anything, ball or bolt, both are same. What is the initial acceleration of the, what is the acceleration of the ball? G10. So we'll write it here. Plus 10. Acceleration of lift is how much? Plus 9. Whole divided by square this one. Now you have to ask questions are why you are writing those accelerations. I think visible. No, see the things. This one I'll write it. So why you are giving signs? What is the, how the ball will accelerate downward? So this will be positive. And what about the lift? Lift is also accelerating downward. This is also positive. So both are positive. Anything directed downward will be positive. So why this is negative? Because you are measuring displacement all from the initial portion. So why you are taking that one? I'm just assuming that the ball may strike the floor. I'm assuming this point. Okay, anything upward, the either displacement, velocity, acceleration should be taken as negative. So why this is plus H? After some time, where the when the ball is about to strike the floor, what about the ball and the floor? They are at same position from the reference level, no? So we are writing plus H plus H. If you want, you write it here. What is this? This point will be origin. Okay, fine. So we'll substitute all the quantities. This will be 0. This will be plus 10. This bracket term I'll write 0. There's a first problem. In detail, I'm trying to write all the things. So 10 minus 9, how much will be 1? This will be t square by 2. So this will be 10 equal to t square by 2. T equal to root 20 seconds. After what time the ball will come and strike? After root 20 seconds, it will strike out 2 root 5 seconds. What will be the velocity of ball and the lift at this point? You can calculate. Velocity of ball, gt, 10 root 20 meter per second. Acceleration of the velocity of the lift when ball is striking, al into t. This will be 9. These velocities we have calculated. So we got time positive. What mean by positive? What does it indicate? Ball strikes the floor of lift. There's a meaning. Okay, sir. If I get negative, what we should conclude? If I get negative, then what we should conclude? Then not possible. If you get time positive, the situation is what you assumed is right. Time negative means the situation is not possible. I think this is very important. If you get time positive, then what you assumed is right. If you get time negative, what you assumed is wrong. So assumption is, what is assumption? That ball will strike the floor. See, I was not knowing whether ball will strike the ceiling or the floor. We don't know. We just made an assumption. I just assumed that the ball will strike the floor. I got time positive. Then what I assumed is correct here. We'll choose the second situation. The same thing. If the lift is same diagram, what is the acceleration given is 11 meter per second square. No, the ball is released from rest. Where do it will strike here? I'll assume that it will strike the I'll still assume that it will come and strike the floor of the lift. Sir, how you can say? I'm not sure. I'm not sure. I'm just assuming it. So this will be the floor, this will be ceiling. Whether we are right or wrong, we'll decide the time. After some time, they will have displacement. I'll assume the same thing. SBL, the same formula. SBL. This is the one I'm trying to make this a very simplified one. Using this formula. Any problem you can solve with this method. Finally, okay, this is again the final. I'm assuming that the ball will come and strike it. This happens at time t. Now once again, sir, why it will strike the floor only? Why can't it will strike the ceiling? I don't know. I am assuming the ball will strike the floor and I'll solve the problem. If I get negative, then what I do? My assumption is wrong. Then after some time t, we'll substitute all the values. This will be plus h finally. Plus h, because anything directed downward will be positive, anything directed upward will be negative. I think the previous one, what I made. It should be negative sign. Okay, fine. We'll start this one. So why you are writing this plus h? At equals 0, ball is here. After some time, the ball will come and strike here. From the origin, at what distance the ball is? At a distance h. And at what distance the floor is? Also h. So both positive, and anything that directed downward is positive. Fine. Next again. We will write this final initially where the ball is at a distance -10. I'll use some other color font, make notice of it, and this is 0 equal to initially both are released from both will start from rest 0 0 t plus acceleration of ball plus 10 downward, acceleration of lift plus 11. So why this is plus 10? How the g for the ball will be? Ball weight of the ball will act, and due to that it will fall freely inside the lift. Then why this plus 11? There's an acceleration of the lift. Then this will be 0. Ten minus 11. This will be minus t square by 2. We have really very important information. So I'm getting t square minus 20. What does it mean? Or t is equal to root of minus 20. So what we did is right, not possible. Huh? Time cannot be negative. So what we assumed is wrong, or ball will not strike the floor of lift. Then what it should strike? It should strike the ceiling of the lift. This is very important. Time cannot be negative. Time should not be negative. Are you getting no? So like this, the mathematics is will help us whether we are right or wrong. Okay, fine. So then what should happen? In fact, this is wrong. Wrong idea or wrong assumption. Wrong assumption. Then what will happen? Yes, what we do is like it. In fact, the ball will be striking the ceiling. I'll write it this way. Okay, this will be ceiling. This will be floor. So this is a situation. So ball, what happened? Will be striking the ceiling. Initially, ball is here. Will come and strike the ceiling. Sir, how do we can justify this? Yes, already we have discussed this one. No? It will not strike the floor, so it is going to definitely going to strike the ceiling here. Now we'll write down the same equations. Huh? Then here instead of H, capital H, I'll write it. Huh? Small h already used. Some other symbol let me use here. The same set of formula. We are not going to change anything now. Complete all the relative accelerated motion. The formula will be same. I think visible. Yeah, we'll proceed. Write down the equations. all the quantity. Again it will be plus H, capital H. And now you have to ask question, sir, why these are positive? Why they are positive? You see this one, the floor of the lift. Earlier it was here at origin. After some time t, it has descended. No, how much of I descended? Plus H. And why positive? Downward, I'm taking positive. Then look at the ball. Ball. What is the final position of the ball will be? Sorry, initial position of the ball will be minus 10, 0, t plus acceleration of the ball plus 10 downward. So plus 10. Depth of the lift is how much? It is also depth of the lift is also will be downward. So plus 11 t square by 2. Okay, from this part. What is L? L I defined it here. Huh? Let me indicate that L. Previous problem. No. What is the initial position of L? The same L is here. Ceiling, that one. The ceiling only. So instead of using word ceiling, with respect to ceiling of the lift, we are writing the equation there. Earlier, with respect to floor, it went wrong. Everything is wrong. What we assumed is now we are trying to do for the second part of the problem. No, initially at t equals 0, what is the position of the ceiling from the reference? Will be minus 20, no? Better distance of minus 20 meters. So that has to be substituted here. Minus 20. So this will become 0. So this will be plus 10, plus 20 minus 10 plus 10 equal to minus t square by 2. So this will be equal to how much? T equal to root 20 seconds. Time we got positive. So t positive, what does it mean? The ball will strike the means what we assumed is right. This what you have to time positive means we'll conclude in this way. Means what we assume that the ball will strike the ceiling. We got the time positive. So therefore, so what we assumed is right. So whether we are right or wrong, who will determine the sign? Huh? Because time should always be positive. So like this, what happens? The relative velocity will be using these conditions. Huh? This is something very important. Everyone should able to understand this. In books, you don't have this discussion. Huh? Just directly they'll assume that no, you should think like this to solve the problem. No, whatever you want, you think it and verify whether it's right or wrong. Now I'm showing the complete description. Look at here once. So we assume that We assume that initially ball will strike the floor of the lift. Then we had a discussion and we have got the T negative, which is not possible. Then we assume that the ball will strike the ceiling. Then we got the time positive. So therefore, what we assumed is right here. Then again, we can find out the velocity of ball lift. Now, with what speed ball will be moving when striking. The same set of formulas. There's a one very important student has to really learn. One problem, if you learn it, remaining things you can manage. I really explain very slowly so that students can really understand. Okay. So these are the some conditions which you should remember. So we'll take the next problem. Okay, students, now we'll go for the next problem. This one. The initial velocity of ball and the lifter as shown. The ball is projected with a velocity of 4 meter per second downward, and the lift, what will happen, will have velocity downward. The lift undergoes uniform retardation. The lift undergoes uniform retardation. Look at the acceleration of the lift. It is upward, no, moving downward, and the velocity of the lift keeps on decreasing. What about the ball? The acceleration of the the velocity of the ball will keep on increase with the time because of the gravity. How the gravity inside the lift will act downward. This at t equal to 0. All these are at t equal 0 condition. After some time, again, I am assuming that after some time, actually it will be here to make you think that one after some time. To draw the diagram, I'm showing it beside. Actually, it should be vertically below. After some time, I'm assuming that the ball will come and the lift will have some velocity. I'm not sure velocity of the lift will be upward or downward. This after some time t. And I'm assuming this has a reference. This has a reference. So this is the like a 2. This is a 1. This will be ceiling. This will be floor. What is the assumption we are making? Let's assume that the ball will strike the floor. So why you are assuming? I should assume any one, no? Either the floor or ceiling. I'm assuming the floor. I'll solve the problem. If I get time negative, what I assumed is right. Or else it will be wrong, that one. Fine. Then, so what about the lift? Yeah, that H you are getting confusion. I'll use Y. Let it strike this one. Downwards are, can you change the convention as upward positive? Downward, I'll take it negative. It's left to you. It's not that always the downward should be positive, upward should be negative. Need not. Here we have changed it. Let's go for some other convention. It's left to you. You can choose upward positive, downward negative, or downward positive, upward negative. We'll write down the same formula. SB, final position of the ball with respect to lift, initial position of ball with respect to lift is equal to initial velocity of ball with respect to lift into time plus acceleration of ball with respect to lift t square by 2. The equations of motion. That only we are applying it. Okay, this is the equation. Let me substitute all. So this bracket, you can notice all the terms what we are using are different. Now we'll substitute the square bracket one. where the ball is. So what are the reference we are taking this one? No? We are taking this as a reference. Reference means that it will strike the floor, we are taking it. What is the final position of the ball with respect to origin will be at a distance y, and negative sign is what I should put it. That of the floor of the lift is also will have displacement y. So I'm taking this as reference, the origin. So initially where the finally where the ball is at a distance y, and where the floor of the lift is also at a distance y. I'm choosing the initial position of the floor as origin. Okay, now we'll substitute the quantities. Initial position of the ball. Ball is at a height 10. The floor of the lift is 0. What about this? Y plus 10. This is the origin. Initially, where the ball is here, at what height? At height of 10 meter. And upward is positive. And what about the floor of the lift? Is at origin. It's 0 equal to initial velocity of the ball minus 4. Initial velocity of the lift minus 20. Now, why they are negative? Velocity of the ball, how it is? Downward. Anything downward should be negative. Velocity of the lift is also downward. Anything downward should be negative. Anything directed upward should be positive. Plus acceleration of the ball will be minus 10. G downward. I'll write. Retardation of the lift will be plus 6. Now you have to really question me. Okay, sir, what is this? Acceleration. The ball, weight of the ball will act. And what do you expect? The ball will accelerate, no? Due to weight. And you are writing minus G. I'm giving here this particular sign for the direction of, but both for acceleration and retardation, we have to give a sign. This is really very interesting. That's why I took the signs in some upward positive, downward negative. And look at the lift. It's a retardation. Retardation upward. That's why it is positive. No, very important. This part is very important. I'll highlight it. You must. Okay. I'm only highlighting those things. G and this one. You shouldn't. But sir, like we discussed in kinematics. In kinematics, we had like acceleration positive, negative. In relative accelerated motion, even for acceleration, it can be positive, negative. Retardation also can be positive, negative, based on the sign. We'll solve now. This will be 0. This will be minus 10. 20, this part, plus 20 minus 4, 16t. Minus 10 minus 6 t square by 2. Minus 10 equal to 16t minus 16 t square, also minus 8 t square. Solving this quadratic equation, I'll get 8 plus, directly I'm writing it, 8 plus or minus root 144 by 8. This will be 8 plus or minus 2 by 8. Negative time not possible, only positive time is what we should take. What is the positive time will be? 20 by 8. 2.5 seconds. So we got positive. So what is the condition now? What we assumed is correct. So what is the conclusion now? In fact, ball will, as T is positive, ball will strike the floor of lift only. If it were negative, then okay, it will not strike that one. So, hoping everyone getting some idea. Huh? This is a method like relative accelerated motion. You should think in this way. We have all the conventions, formulas, everything for our help. This part is 0. This is 0. Like this, we can discuss plenty of questions. The lift accelerating. Okay, kids. Now one more condition I'm bringing. The initial velocity of the ball and the lift are as shown. So look at the ball. It is projected vertically up. The ball is projected vertically up inside the lift, and the lift is moving down and undergoing retardation. What is the state of lift? Lift is moving down and undergoing retardation. What about the ball? Ball is projected vertically up. Then what are the here the G will act vertically down. Something appeared here. Now we'll proceed here. So what is the assumption I'm making it? I'm assuming that the ball will strike the floor of the lift. I pre-drawn the diagram. I'm assuming that you can see clearly the lift is moving down and the ball, what will happen, will strike the floor of the lift. I'm giving some symbols also. We can check it here. We can choose now what will choose origin. Anything we can choose this as the floor of the lift as origin or the ceiling of lift as origin. And let me choose the same ceiling, the floor only. Let it be origin. No? I'll not change it. So no, okay, we'll write down all the equations. Again the same equation. Sir, how the ball will be moving? The ball will be moving like this, and the lift will be moving in this direction. Now, what is the 2? 2 is for the ceiling I'm using. And this is the floor. Now we'll write down the equation. Relative position of the ball with the final position of ball with respect to ceiling of the lift minus initial position of ball with respect to ceiling of lift equal to initial velocity of ball with respect to lift into t plus acceleration of ball with respect to lift t square by 2. Finally, look at here. Finally, where the ceiling earlier, where was the ceiling? Ceiling was at a height of 60 meter initially. Finally, where it is at y, at a distance y. So what is the equation we'll write? Plus y. Both ball as well as lift will be at same position with respect to origin. When the ball is striking the ceiling, then the initial position of the ball plus 10. This will be plus 50. Look at these things are very important. This is the origin we have chosen, and I'll write it clearly. What is the origin? This is the origin. Initially, where the ball is, at height of plus 10 meter. What about the ceiling? Ceiling is at height of plus 50 meter. Nothing is there. Only just make observation. Huh? There's nothing in these problems. We don't have anything. Velocity of the ball plus 6. Velocity of the lift minus 2. Acceleration of the ball g downward. Sorry, retardation downward. That of the lift retardation, but it's upward. Now you have to ask one question. Sir, ball is undergoing retardation and you're writing negative. Okay. Left is also look at the velocity of the downward and the acceleration or retardation is upward. Then this should be negative, but you are writing positive. Here we are giving sign for both retardation as well as acceleration. Retardation of the ball is negative. Retardation of ball is vertically down, and anything vertically down will be negative. Acceleration, retardation of the lift is upward, and it should be positive. So the best example is what I'm giving. Please, all of you, who all trying to learn the concept, you should learn through examples in physics. Relative accelerated motion. Okay, in books open we have this particular formula. So if this formula is enough, yes, you know the formula, but you should also know how to use formula. How to use the formula to the problem. So what is all about the physics? Problem solving. To problem you are going to learn. Huh? Everyone knows theory, concept, they say that one. So until unless you don't solve the different types of problems, you'll never come to know what is that concept and how to use in various situations. This will be 0. This will be 10 minus 40, 80. This will be minus 10 minus of, this will be plus 4. Let me substitute all the values. This will be 40. This will be 40, 80 minus 14, 7 t square. Quadratic equation 7t square minus 80 plus 40 equal to 0. This quadratic equation will solve it. T equal to, this will be 8 plus or minus 8 square minus 4 into 7 into 40. I think time will be negative. 64. Look at all these values. B square minus 4ac. 4 7 are 28, 28, 280. Time will be negative. Let me do the calculation. 28, 28 into 40. 1120. 1120 minus 64. 1056 minus 1056 by 14. T negative. What does it mean? Not possible. I'm giving the idea. So I got T negative. T negative means then what is the wrong that one? Means ball will not strike the ceiling of the lift. Then it will strike the floor of the lift. Then what we have to do? Assume the condition again. So we'll assume it. I'm showing that we can also do wrong. I'm just showing you that it's all possible. Huh? Definitely, we may sometimes assume a wrong situation. So you need not to get scared. Huh? There's no issue that one. Just only the situation went wrong. Then again, okay, the ball in fact will be striking the ceiling of the lift only. I think I'll bring all the cases properly. Huh? This everything is wrong. Huh? Just what we meant. Ball cannot strike the ceiling of lift. Wrong assumption. What is the correct assumption? The correct assumption is no, no. Again, we'll draw the diagram. Huh? I'll draw it. What we are going to assume that we'll assume that the ball, like it's now we had we'll assume like this. In fact, the lift is undergoing retardation. The same values. Huh? Here, what was the value we took? 4 meter per second square. The lift will undergo retardation, and here there's a lift. Inside the lift, what we have done, we have released the ball. We have released the ball. We have projected the ball with a speed ub, and the lift is given velocity, and also it will undergo retardation. Let's assume that the ball will come and strike the floor of the lift. Are you getting this one now? So this was the floor. Already we have checked the ceiling. It cannot strike the ceiling. So I'm going for the floor, that one. So let me substitute this one. So this will be initially, finally, what is the position of the floor? The floor will be at what? From the origin at a height h. Ball also will be at same point. So both this will become minus h minus h minus o. Initial position of the ball with respect to lift, or we have taken this as origin. So initially where it is, the ball is at height of plus 10 meters. What about the floor? Floor will be at origin. This one. This I'll give some other color. Okay, fine. Look at this. This is very important. Look at that red color strip. There is the floor of the lift. Initially, where the floor of the lift? Floor of the lift is at origin, and finally, where the floor of it? At a distance h below the origin. As it ball at the lift. Hmm? So initially, the floor was at origin 0. No, initial velocity of the ball plus 6 minus of initial velocity of the lift minus 2 t plus retardation of the ball minus g minus of retardation of the lift plus al. Already I think in the we have discussed, no? Y minus g, the retardation is downward. Y plus al, the retardation is upward. We are giving sign for acceleration and retardation also. This will be 0 minus 10 80 plus minus 10 plus 4 p square by 2. So minus 10 80 minus this will be 7 t square. So 7 t square minus 80 minus 10 equals 0. I think will be positive this time. 8 square minus of 4 into 7 minus 10 all divided by 2. 64 plus 280 by 2 7 14. 280 plus 64 344 18.54. The positive time only I should take it. Plus 8 divided by 14. 1.89 seconds. And we got positive. So what we assumed is right. So what is the conclusion now? Ball will strike the floor of the lift only. What is the velocity of the ball at this position? We'll calculate velocity of the ball. Velocity of the ball will be Vb equal to Ub minus G into T. Ub is how much? 6, 10. This will be 1.9. We'll take it approximately. So this will be 19. 19 minus 6 will be minus 13 meter per second. So how the ball will be moving? It will be moving vertically down. So inside, what actually happens to the motion of the ball? It will be moving, then it will be descending. And the lift will be, velocity of the lift will calculate. Velocity of the lift. Velocity of the lift will be UL. UL is how much? 2, 4 into 1.9. This I'm getting negative. Negative means, what does it mean? It'll be, lift will be moving up. Getting this idea, I think something. Why negative? Negative means opposite to U value you should take it. So 1.9 into 4, 7.6. So this will be minus. What do you mean by negative sign? Negative sign indicates that when the ball was striking the floor of the lift will be moving up. I think the motion will be very complex. The motion of the ball will be something of like this. And whatever the lift will be, floor of the lift, I'll compare the motion of the floor of the lift. It'll be like this. And the floor of the lift will be of something. Somewhere here they'll collide. I think, look at this one. How the ball will be ascending, then descends. Floor of the lift will descend, then it will start ascending. Somewhere here they'll collide. So how do you can see? I'm having velocity of lift is how much? Negative, means it'll be moving up. And the velocity of ball is overall this idea. Let's give a better diagram. The floor of the lift okay, no, this is the basic concept. After some time you can see the lift, floor of the lift, and there's a ball. I'll give color, you can check it. So how the path of the lift will be, floor of the lift will ascend, will descend, then ascend. Ball, what will happen? Will ascend, then descend, and somewhere they'll collide. A little bit from the data. See, everything I'm checking from the data. I don't have any other thing. With the help of equations only, I'll be concluding all these things. Yes, we'll write it here. Path of ball. This is path of lift. Okay, kids. The relative accelerated motion. I brought almost all the cases. Now you can use that particular formula. So your entire thing is how you are going to use this formula in various cases, and always choose a sign. Upward positive, downward negative, substitute all with sign. Okay, no. Coming classes, I'll come with another some interesting problems. Thank you all of you. Thanks for watching.